Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths Practice Questions on sensible estimates. If you need any extra help on sensible estimates, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 285, there's a dedicated video tutorial there on sensible estimates. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question 1 says, shown below is a glass of water. So we've got this glass of water, and it says below are 4 estimates of the amount of water in the glass, and we've been asked to circle the most appropriate estimate. And the 4 estimates are 15 millilitres, 1.5 litres, 150 millilitres, and 15 litres. Okay, so we've been asked to circle the most appropriate one. So the first thing I'm going to do is I'm going to cross out some which just do not make sense. So 15 litres. If you think of perhaps a bottle of fizzy drink, a large bottle, you perhaps got 2 litres in there. So 15 litres is going to be 7.5 of those big bottles. This glass isn't going to be 15 litres, so that's not going to be the answer. Okay, so 15 millilitres is just far too big. Okay, number 1, 15 millilitres. Now, sometimes whenever you look at measurements in the kitchen, perhaps a spoonful of medicine or something like that, a little spoon might have 15 millilitres. So this glass is a lot bigger than that, so that's not going to be a sensible estimate either. So we've got 2 options left, 1.5 litres or 150 millilitres. Now, whenever I think of perhaps a bottle of fizzy drink, a smaller one that you might buy in a shop, it might have something like 500 millilitres or 600 millilitres. So this glass would look like perhaps a quarter of that. Or even if you think of a can of fizzy drink usually holds about 330 millilitres. And this looks similar to the amount of liquid in perhaps half of a can of a fizzy drink. So to me, 150 millilitres would make sense. That's the one I'm going to circle. And 1.5 litres, again, I'm going to think back to the fridge and think of containers of milk in the fridge. You can get different bottles of milk. You can get a pint of milk, which is about 567 millilitres, something like that. You've got a litre of milk, which is the tall, narrow bottle of milk. You've got 2 litres, which is the bigger one, and 3 litres, which is the really big one. 1.5 litres would be in between that tall, narrow one and the 2 litre one. So I don't think that's going to be the amount of water that's in that glass. So no. So I believe the most appropriate estimate of the amount of water in that glass would be 150 millilitres. Okay, let's look at our next question, question number 2. So question number 2 says, shown below is Jack. So this is Jack. He's a cowboy. It says, circle the most appropriate estimate for his height. And we've got 4 options. 1.8 millimeters. So think of the ruler, those little tiny lines in between centimeters, they're millimeters. So 1.8 of those. Well, no, that doesn't make sense. 1.8 centimeters. So again, think back to your ruler. 1 centimeter, 2 centimeters. So below 2 centimeters. No, that's not appropriate for his height. 1.8 meters. So think of the meter stick in a classroom. So 1.8 of those, 1 and then nearly a second one. I think that's quite a good estimate for his height. And then finally 1.8 kilometers. So think of, if you think of a mile being 1.6 kilometers, that's bigger than a mile. So no, that's not going to be his height. So no. So the most appropriate estimate for his height would be 1.8 meters. And that's it. Okay, let's look at the next question, question number 3. So question number 3. Question number 3 says, Thomas weighs his pet mouse. So he's got a pet mouse and he's weighed it. And it says, circle the most appropriate estimate for the mass of the mouse. So how heavy is this mouse? Is it 25 grams, 2.5 kilograms, 25 kilograms, or 2.5 tons? I'm crossing it out straight away. 2.5 tons. That's not going to be how heavy the mouse is. Okay, so we've got 3 options left. 25 kilograms. Now in my house I've got some weights and I've got a 25 kilogram dumbbell, so that's really heavy, and I don't think a mouse is going to be that heavy, so no. Okay, the next one, 2.5 kilograms. Well, if you go into your kitchen and you find something like perhaps a big bag of flour, it might have a weight of 1 kilogram. So I think 2.5 of those for the weight of this mouse. So no, I don't think so. And then finally, the mass of the mouse being 25 grams. Well, that would be around about right. I think it's quite light. 25 grams isn't that heavy. A mouse wouldn't be that heavy. So yeah, I think that's the most appropriate estimate for the mass of the mouse, 25 grams. And that's it. Now, whenever you're dealing with these most appropriate estimate questions, I think what's quite beneficial sometimes is to think of things that you know, to everyday objects that you can compare it to, perhaps how heavy something else is. And if you know how heavy that is and can compare it to the mouse, then that might help you. Also, if you think back to the previous questions we've looked at, whenever we were looking at the amount of water in the glass, I considered cans of fizzy drinks. I considered bottles of fizzy drinks, bottles of milk, things like that, teaspoons of medicine and things like that. And that helped me as well. Okay, let's look at the next question, question number 4. So question number 4 says, Nicole measures the length of her garden. So she measures how long her garden is, and we've been asked to circle the most appropriate estimate for the length of her garden. And we've got 23 millimeters. So again, there's little dashes on the ruler, so in between centimeters, the millimeters, 23 of those, just over 2 centimeters. No, that's not how big her garden's going to be. 23 centimeters. I suppose in theory it could be 23 centimeters, just a bit shorter than a bigger ruler, but I don't think that's going to be the case. 23 meters or 23 kilometers. Well, 23 kilometers makes more sense for distance between towns, unless she's got a humongous garden that goes longer than the distance between towns. I think 23 meters would be the most appropriate estimate for the length of her garden. Okay, let's look at our next question, question number 5. So question number 5 says, Olivia measures the thickness of a key. So she's got a key and she measures how thick it is. So she lays it down and measures how thick it is. And we've been asked to circle the most appropriate estimate for the thickness of the key. And we've got 3 millimeters, 3 centimeters, 3 meters, or 3 kilometers. Now it's not going to be 3 kilometers. Again, that's quite large. They're quite big distances. Perhaps a distance between 2 villages, something like that. Then we've got 3 meters. Again, the thickness of a key, it's not really going to be 3 meters. So I would tend to think, if I want to estimate how big 3 meters is, I would normally think of a doorway having a height of roughly 2 meters. So then another meter stick on top of that would be 3 meters. That's a very thick key, so no. 3 centimeters, again, if you look at your ruler and look at 3 centimeters, for how thick the key is, not how long it is, how thick it is, I think that's too thick as well. Whereas 3 millimeters, if you look at those little dashes on the ruler, in between centimeters, those millimeters, for the thickness of the key, I think 3 millimeters would be the most appropriate estimate for the thickness of the key. Okay, let's look at our next question, question number 6. So question number 6 says, Jessica measures the height of her 10-year-old son. And we've been asked to circle the most appropriate estimate for the height of her son. And we've got 14 meters. Well, again, a doorway, 2 meters, 14 meters for her 10-year-old son. Nope. 14 centimeters. Again, if you think of rulers, you've got the bigger rulers that you might have in your pencil case, which is the bigger ones, and maybe sometimes they fold in half, but those bigger ones are 30 centimeters. The smaller ones you get are normally 15 centimeters in terms of the height of her son. Nope. 1.4 meters or 1,400 centimeters. I'm going to change this 1,400 centimeters into meters just so I can understand how large this is. So there's 100 centimeters in a meter. So if you divide this by 100, that would be 14 meters. So that's the same as this one. So no, that wouldn't be appropriate either for the estimate for the height of her son. So the estimate that would be most appropriate for the height of her son would be 1.4 meters. And think about it. 1.4 meters is 140 centimeters. A meter stick in a classroom is 100 centimeters. And then if you've got 40 more centimeters, well, a bigger ruler is 30 centimeters. If you put that on top and then over 10 centimeters, that would be appropriate for the height of a 10-year-old. Okay, let's look at our next question, question number 7. Okay, it's question number 7. Question number 7 says the scale diagram shows a man and a lorry. So this is a scale diagram. It's been drawn to scale, and we've got this lorry and this man. And the man has got a height of 6 feet. So he's got a height of 6 feet, and we've been asked to estimate the length of the lorry in feet. Now, before we do this question, I just want to point out that I'm going to do this question based on the measurements that I've done whenever I've printed out the worksheet. So I've printed out these worksheets from the Corbettmaths website on A4 paper, and then I've measured them with my ruler, and I've got some measurements. So I'm going to use those measurements today. If your teachers printed this, they may have perhaps printed this as 2 sheets per 1 sheet of A4, so that might affect the scale of it and so on. So what I'm going to do is I'm going to use the measurements that I've got whenever I've measured it on my piece of paper. Okay, so in terms of this question, what I want to do is I want to measure the height of the man, and I want to see how many of those would fit along the lorry, and then that means that we could then see an estimate of how long the lorry is. So in other words, what I want to do is I want to see if I had this man and I laid him down and again and again and again and again, how many times he would fit in for the length of the lorry. So what I've done is I've measured the height of the man on my piece of paper, and I've got that to be 2.5 centimeters. So on my paper I measured it to be 2.5 centimeters. Then what I've done is I've got my ruler and pencil, and I've marked off where the end of the lorry is here, and I've gone along to where the beginning of the lorry is there, and I've done that. Then what I've done is I've then put my ruler here at the beginning, so 0 is here. So I went along 2.5 centimeters and I've done a dash because that would be the height of one man. Then I went another 2.5 centimeters, so that would be 5 centimeters in total, and then I've done another dash. Then I went another 2.5 centimeters and then I've done another dash. And then I went another 2.5 centimeters and I've done another dash. And then I went another 2.5 centimeters and done another dash. And then I found this to be roughly another half of the 2.5 centimeters. So I found that there'd be 1, 2, 3, 4, 5 5.5 men. So I found that he would fit into this distance 5.5 times. He could lay down one, then another one, another one, another one, another one, another one, and then a half, and that'd be 5.5 times. So then, because it's a calculator question, I figured out, well, if he's 6 foot tall, so in real life, if he's 6 foot tall, if we take his height, which is 6 foot, and we multiply it by 5.5, so 5.5 in our calculator, that would give us an estimate for how long that lorry is. So 6 times 5.5 is equal to 33. So that's 33 feet. And that's it. That's our estimate for the length of the lorry. And I just done it by measuring his height, which was 2.5 centimeters, and then just kept on measuring 2.5 centimeters and found out there was 5.5 of them. Now, sometimes with these questions, it'd be a bit nicer, where it's maybe 6 of them or 7 of them exactly. And then you can just do 7 times 6, and then that's your answer. And that's it. But this one was about 5.5. So that meant that our estimate for the length of that lorry is 33 foot. And that's it. So let's write that down. 33 feet. Okay, let's look at our next question. Question number 8. Okay, question number 8, we've got this house and we've got this girl, and the question says the scale diagram shows a girl in a house. So we've got this girl in the house, and it's a scale diagram, so it's drawn to scale. The girl has got a height of 1.5 meters, and we've been asked to estimate the height of the house. So what I've done is, and I've gone by my printout, my A4 printout, so I've measured the height of the girl, and the height of the girl on my piece of paper is 2 centimeters. And then what I've done is I've got a ruler and pencil, and I've marked the top of the house, and I've gone down to the bottom of the house, and I've measured the height of the house, and I found the height of the house to be 12 centimeters. So I've measured the girl, I've measured the house, and I found the girl has a height of 2 centimeters on my paper, and the house has got a height of 12 centimeters on my paper. So then what I've done was I divided the height of the house, 12, by the height of the girl, 2 in centimeters, and that is equal to 6. So that means that the house is 6 times taller than the girl. So that means if we want to estimate the height of the house, we just need to take the height of the girl, which is 1.5 meters, and times that by 6, and that'll give us our estimate for the height of the house. So if we want to times something by 6, we could times it by 2, and then times it by 3, because if you times something by 2 and then by 3, then that's the same as timesing it by 6. So if you double it, that's equal to 3 meters, and then times that by 3 would be equal to 9 meters. Or to calculate a question anyway, so you could just do 1.5 times 6 in your calculator, and you get that's equal to 9. So our estimate for the height of the house is 9 meters. And that's it. So again, just to recap, I measured the height of the girl on the paper to be 2 centimeters. I measured the height of the house on the paper to be 12 centimeters. I divided the height of the house by the height of the girl in centimeters, and I found that was equal to 6. That means the house is 6 times larger than the girl. And because it's to scale, that means in real life, the house would be 6 times taller than her height. So I would do 6 times 1.5, and that's equal to 9. And that's it, so 9 meters. Okay, let's look at our next question, question number 9. So question number 9, we've got this dinosaur and we've got this man, and the question says the man is 6 foot tall. Is that Jack from earlier on? Did we have him earlier on? And we've been asked to estimate the height of the dinosaur or the T-Rex. So what I've done again, I've printed out the piece of paper and I'm looking at the measurements on the piece of paper here. So I measured the height of the man, and again I found his height to be 2 centimeters on the piece of paper, and I measured the height of the dinosaur. When I measured the height of the dinosaur, I found that the dinosaur had a height of 10 centimeters. So that means that if we divide the height of the dinosaur on the paper by the height of the man on the paper, so if we do 10 divided by 2, that'll tell us how many times larger the dinosaur is than the man. And because this is a scale drawing, then that will tell us how many times bigger the dinosaur is than the man in real life. So 10 divided by 2 is equal to 5. So that means the dinosaur is 5 times larger than the man. So if we take the man's height, which is 6 foot, and we times that by 5, that'll give us our estimate for the height of the T-Rex. So 6 times 5 is equal to 30. So that means that our estimate for the height of the dinosaur is 30 foot. So let's write that down, 30 feet. And then if we carry on, we've been told that 1 foot is approximately equal to 30 centimeters. And we've been asked then to give our estimate in meters now. So we need to change 30 feet into meters. Now we're told that each foot is 30 centimeters, or roughly 30 centimeters. So if we take the 30 feet and times that by 30 centimeters, so 30 times 30, that's equal to 3 times 3 is equal to 9, and then we add 2 zeros. So that means the height of the T-Rex is roughly 900 centimeters. But we want to give our answer in meters, so we need to divide that by 100. So dividing that by 100, we can take off the 2 zeros, that will leave us with 9. So 9 meters, that's our estimate for the height of the T-Rex, 9 meters. Okay, let's look at our next question, question number 10. So question number 10 says, shown below is a scale drawing of 2 buildings. So we've got building A and building B, and we're told that building A has got a height of 14 meters, and the question says the height of building A is 14 meters, work out the height of building B. So we want to work out the height of building B. Okay, so what we're going to do here is, again, on my piece of paper, I'm going to measure the height of building A and building B. So I've printed this out and I've measured the height of building A, and I found that to have a height of 1.5 centimeters. When I measured it, the height of it, I got that to be 1.5 centimeters. And then I measured the height of building B. So I measured the height of building B on my piece of paper, and I got that to be 7.5 centimeters. So that means we've got the height of the two buildings on the piece of paper. So if we divide the height of building B by the height of building A, we can see how many times bigger building B is than building A. So if we do 7.5 divided by 1.5 on our calculator, that's equal to 5. So that means that building B is 5 times larger than building A. So if we take the height of building A, which is 14 meters, and we times that by 5, that'll give us the height of building B. And if we do 14 times 5, that's equal to 70. I remember our units is meters, so 70 meters. So the height of building B is 70 meters in real life. And that's it, so 70 meters. Okay, let's look at our next question, question number 11. Okay, so question number 11, we've got this lighthouse and this man, and we're told the man has got a height of 1.8 meters, and we've been asked to estimate the height of the lighthouse. So we want to estimate the height of this lighthouse. So what I'm going to do is I'm going to get my printout. I've printed this out on A4 paper, and the height of the man on my paper is 2 centimeters. So that's the height of the man on the piece of paper whenever I measure the height of him on the piece of paper. And then if we measure the height of the lighthouse on the piece of paper, I found that to be equal to 16 centimeters. The height of the lighthouse is 16 centimeters. So if we divide the height of the lighthouse, the 16 centimeters, by the height of the man, which is 2 centimeters, that's equal to 8. So that means the lighthouse is 8 times larger than the height of the man. So that means if we take the height of the man, which is 1.8 meters, and times that by 8, because the lighthouse is 8 times larger, that'll give us our estimate for the height of the lighthouse. And 1.8 times 8 is equal to 14.4. So our estimate for the height of the lighthouse is 14.4 meters. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on sensible estimates. If you need any extra help in sensible estimates, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 285, there's a dedicated video tutorial there on sensible estimates. Alternatively, you could scan this QR code. But in this video, we'll focus on the video solutions to the practice questions. I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to my YouTube channel. Also, I just want to leave you with the thought that whenever you're dealing with sensible estimates, it can be quite useful to be aware of those everyday objects around you. So be aware of how heavy perhaps an apple is, or weights in your house, or a bag of sugar, or a bag of flour. Be aware of how long some everyday objects are. So how tall is a door? How tall are you? How long is a meter stick? It's a meter, but it's quite useful to compare that to everyday objects. Also be aware of how much liquid's in a particular container. So a bottle of milk, how much liquid's in a bottle of milk, or a bottle of fizzy drink, or something like that, or a can of fizzy drink. So knowing those can be really useful whenever you're dealing with sensible estimate questions. And that's it. Thanks very much. Cheers. Bye.